Hey, this chapter is about metal forging processes and their equipment. We were talking about some fundamentals of forging processes, and then we'll discuss some types of machines, types of kind of equipment which can be used in these manufacturing processes. And with the help of forging, actually, we can produce small things, small parts, larger parts, and there are, for instance, like gears, balls, some blades, some tools. So with forging process, we can produce various types of products. And this process actually were one of the oldest type of manufacturing processes. Even people were doing these type of forging processes about 4000 BC before Christ, and they were simply putting material on a table and then applying force, applying some using some hammers and other maybe stone to shape the material. And this is one of the primitive type of forging processes. In some cases, we may use a simple table, or in some complicated forging operations, we may have a specific die and then try to put material into that die, and later the material will take the shape of the die. We'll talk about these, but in all forging processes, we need to have compressive forces. We need to be applying forces on the workpiece, and with the help of these forces, we'll be shaping the initial workpiece. And another thing about the forging process is that we are just a discrete process, which means that we are producing the workpieces one by one. It's not roll like rolling or let's say extrusion or other kind of mass production things. It's a discrete process. We process them one by one. After one is ready, then the second workpiece is processed. And the advantage of the forging process is that we will discuss that due to the grains, due to the arrangement of the grains, they usually have better strength and toughness. So that's why actually in automobile industry, this process is highly utilized. Most of the parts like shafts, cams, other kind of gears are all manufactured with forging processes. And the earliest one, the simplest type open die forging is done by blacksmiths in the earlier days. Now we'll discuss these operations, these fundamentals. We can see some examples that may produce like small parts, knives with forging, or even like very large products. You can see a typical machine here for a larger product. It's a huge press. They are applying compressive forces on the workpiece. Workpiece is usually put here under here, and then with huge forces, they are shaped. This is actually the thing I mentioned, the orientation of the grains. You'll see if you cast a product, that will be the type of grains, and we will have dentring type of structures. If you do machining, you see the grains, the order of the grains are not modified. We only remove material. But if you do forging, due to the compressive forces, actually, you have grains around the boundaries. And this is highly effective in increasing the strength and the toughness of the workpieces. So we always want to have actually such grains in all the products. And we can perform this forging process at room temperature. And if that is the case, the processes are called as cold forging. But if you increase the temperature a little bit, it's called warm forging. But if the temperature is above the homogeneous temperature, then it is named as hot forging process. And obviously, if the temperature is lower, then the ductility is lower, and you need to apply more forces to shape the workpiece. But if you increase the temperature, then with less force, you can do the same operation. And the advantage of cold forging, as in the case of cold rolling processes, we have better surface quality, its accuracy is much better. But the advantage of hot forging is that with less forces, since material is a bit softer, you can shape the workpiece. And the problem with hot forging, you know that the accuracy and the surface quality is not as good as it is actually in cold forging process. Now let's briefly look at open die forging. As I said, it's one of the simplest ones. We have a table. We simply put our workpiece on this table and then try to shape it with some compressive forces. We may be using a hammer, as actually blacksmiths were doing in the earlier days, or you may be using a professional press. Press going down and shaping your workpiece. And with the help of this process, we can produce smaller or larger products, like as you see, pins, nails, bolts, or some propellers of the ships. And we sometimes call this process also upsetting or flat die forging, but they're all the same. They can be considered as open die forging. And I can show you some examples of it. You see, this is the initial stage of this open die forging. The upper part and the lower table can be considered as part of the die, but I can say that this part is actually the table, and then with the help of our tool, we're applying compressive forces on the workpiece. You see, initially we have a D0 of diameter, H0 of thickness, but later this thickness is decreased and the diameter is increased. And at some point, you may have the effect of barreling. Actually, this is due to the frictional forces. So we have such a curve on the side surfaces, and it's an important phenomenon in forging, especially in open die forging, since we don't have any forces or any limitation on the side surfaces. So we always have some amount of barreling. So depending on the friction between the tool and the workpiece, this might be much or lower, but in all open die forging process, you have some amount of barreling. And here we have a table actually summarizing some forging process. You may have a look at it later, but I can say that in open die, things a bit simpler, not expensive actually, since you don't spend too much time on the design of a die. We have a table and we simply apply forces. But in the closed die, we will see that things are a bit complicated. You need to design the die properly, use some correct amount of material. So that's why it's a bit expensive. But the advantage is that its service quality, its accuracy, is let's say mechanical properties are much better. And here are some other types of open die forging. You see, you may be working on simple box shapes or ring shapes or cylindrical shapes. It doesn't matter. But if that is the case, if the part is a bit, let's say, round in shape, then you need to be rotating it from time to time so that the whole surface can be forged. And it's also the same for this ring shape. If you only forge this part, then we will not have uniform thickness throughout the ring. So that's why once this part is forged, we need to rotate the ring a little bit and then forge the second part and do this process until the whole ring is actually forged. Now, I'm not going to talk about these modeling, these equations, the forces in this process, as in the next year, in 303 course in manufacturing engineering course, you'll be focusing on these issues. So I'm skipping this part, but now we will focus on the second type, closed die forging and impression die forging. They're highly similar to each other. You will see that there's a little difference in between. But the thing is that we are obviously making use of a die set. You see, we don't have flat dies. We have some cavities, and other cavity is also available on the upper die. But the process is simpler. We put our workpiece in between and then apply compressive forces. Try to shape the material. You see, at the beginning it's called a blank, but later it will take the shape of our die. And in some cases, if you put actually more material, then you'll have some flash around this, you see, around this die. And that means if this process is not completed, you need to do some post-processing. Maybe trimming operation or machining operation should be performed to remove these flashes. Since this is not a desired product, so we need to do extra operations. And these are the things, as I said. And in order to decrease the forces required in these processes and impression die or closed die forging, we usually do it at high temperatures. And with the help of high temperatures, obviously, the amount of force required is decreased and the ductility of the workpiece is increased. So it can easily move into the cavities and the workpiece, the blank material, will take the shape of our die. Here's another example, as you see. And in some cases, people actually leave or provide some spaces intentionally for the flashes, since otherwise, if you don't provide extra space, then there might be too much pressure on your die, and you may harm your die, and you cannot use them for many times. So that's why it's better you actually give some space to the flash material, so that the pressure on our dies are not too much. Here's an example showing some stages of actually closed die forging. You'll see initially we start with a cylindrical shape, do some edging. By the way, edging is actually about the distribution of material. With edging, we distribute more material at the center and decrease the amount of material at the edges. And with fluorine, actually, we decrease the amount of material at the center and increase the amount of material at the edges. So depending on your case, at some point of your forging process, you may go with edging or fluorine. So in the second stage, edging is performed, and then we do some blocking, or again, some simple forging operation. You see, now we have too much flash around. And lastly, we do some extra forging operation so that the desired shape is obtained. And lastly, we need to get rid of this flash, and this is called as trimming. Now let's have a look at the difference between the impression die and closed die forging. In the closed die forging, actually, it's almost the same. The difference is that we don't have any flash. So that's why actually from time to time, people call it as flashless forging. You can see it here. This is closed die forging. You see we have flash, but in the flashless forging or closed die forging process, we don't have any flash around. So the material, the initial blank material is actually has the desired amount of material. So this is actually the critical issue in closed die forging. You need to make your calculations, analysis properly, so that you don't put actually extra material into this cavity. Since if you put too much material, then our upper punch will not be able to close this opening, and your process cannot be completed successfully. So the engineering side, engineering analysis are actually more complicated in the closed die forging. Now let's have a look at some types of forging processes. The first one is coining, and it's especially utilized to manufacture very small products. You can see some example. As the name implies, obviously, we are producing coins, and very similar to the previous process we discussed, flashless forging. You'll see in coining again, we are not producing any flash, but the thing is that the parts are smaller and we are applying too much force. And we can have indentations, some kind of figures, some extra patterns on the tool. It doesn't matter. So it's a very productive production process or mass production, especially for the mass production of smaller parts like coins. You can use this coining process. Then we have heading. Again, as the name implies, with this process, we obtain the heads of some bolts, screws, kind of things, in order to eliminate the buckling problem. We make use of some obvious dies. You see, if you don't use such a die and apply pressure on this side, then probably it will buckle. It will be bended, and you cannot successfully complete this process. And you see, with heading process, we obtain such heads, and this is mostly utilized in the production of, let's say, bolts. And I may show you some example products while we are discussing these issues during the live sessions. Then we have piercing, another complicated process. Again, we have our die, put our workpiece, and this time we are actually trying to obtain some indentations. You see, we have such kind of a closed hole. We have an actual picture here. You can see the flow of the grains, the material easily here. With the help of it, we obtain such features on the top surface. We have some other processes like isothermal forging. And this is also known as hot die forging, since the temperatures are increased. You also heat the die so that it has the same temperature with the workpiece, and they have the same temperature, the workpiece and the dies, and things are much easier. We don't have heat flow in between the workpiece and the die, so things will be much easier. And we do this process on very difficult materials, larger products, which cannot be easily actually formed with cold die forging, or where in forging cases where the temperature of the, let's say, dies are around room temperatures. Then we have different type of forging process called as rotary swaging, and I would like to explain this one on the figure here. This one rotary schematic of an rotary swaging. So what we do actually, we try to decrease the diameter of the pipes, tubes with this rotary swaging process. What we do, we have many hammers. You see this one hammers, and we have 4 of them. So we put our workpiece at the center, and then due to the rotation of these rollers, planetary rollers, sometimes this hammer will be going up, and once the rollers are not at this point, they will be actually going up, but once the roller is at this tip, then our hammer will be going down. So you have a kind of an impact force always on the workpiece, and if you have it from all sides, up, down, right, and left, then we will be actually decreasing the size of this circular shape. And I will show you some videos about it. And we can do also internal version of it. This is the same principles, but this time we are applying these forging forces from the interior of the pipe or tube. And again, our aim is to increase the diameter of this tube. But this time, in the A case, we are trying to decrease the size of our product. And it's called, the last one is called as tube swaging. This one here is the tube, and if you do apply swaging on it, then the internal diameter will be increased, the thickness of the walls will be decreased, but we will have a larger tube. In the rotary swaging case, since we are applying forces, forging forces from the outer surface, we are decreasing the diameter. Let's briefly talk about the forgeability. It's not complicated. It's very similar to machinability. If any material actually can easily be forged, then we can say that its forgeability is higher. And it's highly depending on the ductility of the material. If it's quite ductile, then we can easily forge it. So there might be such a relation between forgeability and ductility. And the thing is that actually, if you are doing some forging operations on it, then you shouldn't have any problem in that material. You shouldn't come up with some cracks, some other impurities, some non-uniform properties. The material should be fine, and the resulting workpieces shouldn't have any cracks if that material has high forgeability. You can see some typical products obtained by swaging. You see, this is the initial diameter, and then after swaging, the diameter is reduced. Now, these parts are not that important, but we can focus a bit on the machines we are using in the forging processes. You see, there are main 4 types of forging machines. These 2 are similar. This is called as crank type of, let's say, presses or forging machines. We have a kind of an actually rotational motion here, and this is a kind of a slider crank system mechanism. With this rotation, we change this the type of motion to a translational motion on this ram, and with this ram we apply compressive forces on the workpiece around here. And it's also the same in the knuckle joints, but we have some limitations here. The force limitations with knuckle joint, we may improve the amount of forces you are applying. Then we have a script type. You see, we make use of flywheel. So we transfer the energy of this flywheel onto this screw, and then ram goes onto the workpiece. Then on the last case, we have the hydraulic type of presses, and the advantage of them is that their forces are quite higher. So if you are trying to forge difficult materials or larger workpieces, you may go with hydraulic type of forging machines. So you see some typical speeds of these processes, these machines with hydraulic systems presses. We have less speed, but their pressures, their forces are higher. So mechanical presses are again a bit faster, but not too much. Screw press is almost the same, but I will discuss that. The gravity drop hammer is higher, the speed is higher. In the power drop hammer, it's about maybe 6 meters per second, but in the counter blow hammer, it's much better. Now let's talk about these types of let's say presses. The mechanical ones are the A and B, this crank and knuckle joint. And the advantage is that in the knuckle joint, actually, we have more forces, higher forces compared to the crank system. But the disadvantage of the crank system is that it's stroke limited. It depends. The stroke depends actually on this diameter, the length of this, let's say, crank. Then we have screw press, and we have limitations in terms of energy of this flywheel. So it may not be able to increase the energy, the pressure you are applying on the workpiece. So it's limited by the flywheel you are using in this screw press. And in the hydraulic case, actually, it's load limited since you are using a pressure supply, hydraulic pressure supply. The maximum pressure you can apply is limited by that system. But the thing is that obviously it has the highest force among the other presses. But we know that it's the slowest one, so you should be careful about these properties and then decide the right, let's say, forging machine, forging press for your company. And in addition to these, we also have some hammer types, and these are simple hammers. If you don't apply any extra force, and if you simply drop this hammer with the help of gravity, it's called as gravity drop hammer type of equipment for forging. But if you apply some extra pressure in addition to gravity, then it's called as power drop hammer. But if you use two hammers at the same time, it's called as counter blow hammer. So that's why actually the forging speed is much higher compared to the other hammer type processes. And it's a typical actually press you see. It's a servo press, and it can apply this much of force on the workpieces. And this is actually all for this chapter. Please make sure that you have a look at the review questions and qualitative problems, and see you in class.